Hello everyone, this is
Jake Pardo
and Jason Schroeder here. Just wanted to cover I don't even know if it's a lean idea. Yeah, it's probably not, but it's more of a communication idea where we have a really neat practice and something that's really neat in the pre-construction phase of the project, and we wanted to share it, and Jake did a good job, and so I wanted to showcase it a little bit. So it deals with, can you flip to the table on the drawings that had the original coordinates? Typically when we get our sets of drawings, we might have a design benchmark, and we might have a basis of bearings. We might have points that the surveyors and designers use to lay out the building. At Pharmacy, we have, real quick, can you explain what Pharmacy is, how it ties in?
College Pharmacy is an addition expansion that's being built over top of an existing building. So we're adding 2 more floors to an existing building and enclosing a walkway.
So basically, when you look at, and I don't know if you can see this, and you don't have to zoom in too much or at all, but on CS 101, basically the front matter of the civil drawings, it has a point table, and it says grid line 10.1 and 1.7, here's the coordinate, 6.6 and D.9, here's the coordinate. So it's given us 4 coordinates, but those coordinates will tell us where our new building is. How do we know that it fits and ties into the existing? Does that make sense? Mm-hmm. So what Jake here did, which I thought was really cool, Jake and Taylor and JC and the whole Pharmacy team, forgive me if I left somebody out, but they went through, if you can zoom out a little bit, and in AutoCAD did what's called a traverse. And if anybody ever needs to know how to do this, you can reach out to a couple of people. Taylor knows, Jake knows. There's a couple of us that know how to do this in detail, if you ever want to reach out. But basically the surveyors provided points, and there's a system called traversing where we were able to analyze those points. So that's step 1. Step 2 is we took shots with the total station over to the existing building, and it's not shown exactly on this drawing, but we took as-built points of the existing building and sent them to the designers and said, is this right? Like, if I do this, am I going to have the right expansion, between the building? Am I going to have the right expansion joint? Will my steel structure fit? Will all the elevations fit? Because in this loop, we looked at X, Y, and Z, which is elevation. And then from there, the designers gave us feedback. Yes, these coordinates are correct. Yes, these elevations are correct. And then Jake put together this plan. So Jake, I'd like you to zoom in right here. And this is basically your primary, secondary control plan. Can you just briefly take me through that and just kind of point to the components there?
So the red lines are the grid line layouts. So this is where all of our grid lines will be for the building. All labeled here, 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 up there, and across. The yellow lines are going to be our building control points. Those are set up with a typical 5-foot offset. So once we start getting the building, we can keep our control points on there. So these will be our building control layout for this.
Let me just say one thing. So to Jake's point, you can set up a total station. You can set up a robotic total station anywhere. If you set up a conventional total station, you can set up backside, meaning getting a 0 reference, turn 90, and be able to lay out anything that you needed for the red grid lines. Go ahead.
So what we did is we laid that over top with the 4 points. So the 4 points that were given in the plans were the 4 corners of that grid line. We were able to take these points in there, put them in, and see how close we were getting to from our surveyed control points. These were essentially the typical points that were in here. We found that there was a little bit of error involved in that, and that they didn't take it out to enough decimal points, so it didn't allow us to close everything correctly. So in putting these points in there and measuring everything off, we got essentially the same thing if you were able to round up a little bit more. The green lines that you see here and here, those are the outside face of our existing building that was sent over to the engineers for approval. They were able to tell us, yes, where our control points are, where we're going to lay out the building is gonna be correct. And right now, we're in the middle of laying out those yellow points up here, which are our building control points. And as we're setting that up, like Jason said, we'll be able to set up a conventional total station without having to bring a robotic on, and able to just really simply turn 90 degrees and lay out a point, which will help us when we're getting close to putting in our caissons, putting in our anchor bolts, and making sure that we have the correct distances for all those, so that as the structure goes up, we're not having to do any rework or RFIs to change any of that.
I think that's a perfect point. And Lord, just make sure that I'm always looking forward. I don't want you to like get my bad side. Anyway.
I can cut it up.
So you were right, Jay. I didn't see them, but the green is the existing building. So the architect was able to run dimensions of the actual location to where the new building will be all the way around and make sure it fit. And the reason that we do this is A, make sure the surveyors didn't get us like 5 foot in the wrong spot. B, surveyors usually just give you a kind of an accurate point, but it's not tied in precise one to another, meaning you could go lay out from this point, lay out over here, lay out from this point, be a ½ inch different. That's another reason you tie those points together, right? Mm-hmm. And then when you're doing these points, exactly what Jake said, to reiterate, if these are all precise, and if this line intersects nicely with this line up here, then everything will fit, the steel will fit, the floor edges will fit, the elevations will fit, and we won't have fee erosion, well, as much fee erosion from having to level floors, having to write an RFI, having to modify the steel, having to drill an epoxy, having to move an embed, things like that. And so, just to summarize everything, if you can zoom out, Jake, we took the design benchmark and the X and Y of all the surveyors' points, traversed them, and then we took as-built locations of the tie-in building, X, Y, and Z, confirmed that the building is in fact where the designers wanted to go and that those points were right, and then allowed, Jake enabled his team to go put control points out there to reduce or eliminate fee erosion from mistakes and from not having a precise network of control. And just in case anybody's curious, where this green is, the existing building also goes down and over, and we have renovations. We laser scanned all of it, we took elevations around all of it, we did an as-built of everything. So we know when we tie into that building, we're not gonna find a floor that's high, it's not gonna be offset, we're not gonna have the wrong size gap. We did that at BSRL 2, and it was fantastic. One of the lessons learned was maybe just taking it a step farther. So when you're setting up the job site control, the bottom line is, we cannot just trust surveyors to give us points. There's a QC system where we have the opportunity to reach out, get another set of eyes, and make sure that everything that we're doing is being built in the right spot. Anything else you want to say?
One of the things we're planning on using it for is allowing us to check edge of slab as well. Check for alignment with it, because if we're able to turn 90 degrees, we'll be able to check exactly where the edge of slab is going to be, which should be this line right up in here. So as you get into this more, and most people have some basic understanding of AutoCAD, this is very basic for your layout. It's pretty easy to check with a couple of tips here and there. Anyone can really become pretty proficient at doing this in their own at their own computer.
Okay. We love you guys. Thank you, Lourdes.